All right, now that you have read that first page of section 7.4 and you hopefully understand why these facts are true, or at least somewhat, it's a tricky concept, but I think that page explains it pretty well. Anyways, let's look at how we can then use these properties of logarithms to manipulate expressions with logarithms in them. So we're not actually changing them, but writing them in a different format, but doing so according to these rules. So first, let's say you have one big complicated logarithm like this. It's got a square root, it's got some multiplication inside the square root. How can we break that apart into simpler logarithms? Well, the first thing you can do is realize that the square root, you could write it as an exponent. So this is the same thing as log of xy to the power 1/2. The exponent 1/2 does the same thing as a square root. So then once it's written that way, you can see that that is written as log of something to a power, so you can rewrite it out in front as a coefficient and write this as 1/2 times log of xy. And now this looks exactly like this property 1 here. We have log of a product, something times something. We're going to break that into these two separate logs like so. And that's going to look like 1/2 times the product log of x plus log of y. Did I say the product? I meant the sum because we're adding there. And make sure you have the parentheses around it because you were doing 1/2 times this whole thing, and that whole thing got turned into this. So you want to have the 1/2 multiplied by all of it. Or if you don't want to write the parentheses, you could just distribute it and write it as 1/2 log of x plus 1/2 log of y. So either one of these two ways is a perfectly fine way of writing that answer. So yeah, it's broken into simpler logs now. Let's look at this one too. Here, the first thing I want you to notice is that the exponent 4 here only applies to the m. The 3 is separate. If it was 3m all raised to the power 4, it would look like this. Log base 2 of 3m, in parentheses, 3m to the 4. And then that we could write as 4 times log of 3m. But that's not what we have. This is different. Because it doesn't have the parentheses around the 3m. So in other words, this isn't actually an exponential thing. We can't actually use this property 3, but what we can use is property 1 because it's written as 3 is like one of the factors. The other factor is m to the 4th power. So we can do that as this, separating it out into a sum like so. So that's going to look like log base 2 of 3 plus log base 2 of m to the 4th power. So then we can now say we have this 4th power exponent here. Now we can use this rule 3 now and bring that 4 down as the coefficient. So now it's going to look like log base 2 of 3 plus 4 times log base 2 of m. And that is a different thing than what we would have gotten if you made that mistake in the beginning. You'd have the 4 multiplied by both of them. But that's how that one works out. We got it separated into simpler logs now. So now that we've been splitting logs, like you would do with an axe, now we're going to combine smaller logs into big logs. I guess you'd have to use glue to glue these logs together. But the glue we're going to be using is, of course, these logarithm rules, but we're going to be going from right to left now to combine simpler or small simple logs combined together into one big log. Okay, so for this one, there's a few different ways you could do this. I want to focus on one way first, which is going to be, first of all, this thing here, because it's written as something times a logarithm, you can write that thing as now the exponent. So that's going to look like log base b of x to the power 3 using rule 3 there. And then this one we still have, I'll just write that as minus log base b of x. And now you can use rule 2 because we have subtraction going on here. And so we can turn that into a log of a quotient like on the left side. So that's going to be log base b of x to the power 3 over x. And then you might realize x to the power 3 over x is just x squared, right? Because one factor of x cancels out. And that's about as simplified as you can get that. And I want to point out that there's another way to do this here. So if instead of doing it this way, what if we just combined like terms, said that I have 3 times something minus 1 of that. If you just combine like terms here, this would look like 2 times log base b of x. And then once you see it that way, you could just turn that into log base b of x to the power 2. This time using the rule 3 at this point. Ben, you get the same thing, so that's good. So 2 ways to get that same answer. Always helps. So now let's look at how we can combine this into one big logarithm. First, because you have a log plus a log, that means we can use rule 1, where on the right side you have a log plus a log. So that's going to look like log of just x times y. And I'm just leaving the 7 alone. But now that it's 7 times a logarithm, that looks like the right side of the, the right side of the third one here. So I can then turn that 7 into an exponent and rewrite this as log of xy to the power 7. And if you like, you can use one of the exponent rules to turn this into log of x to the 7th times y to the 7th. But either one of these answers is fine. Okay, so it's kind of tricky stuff. Here's one exercise for you to try. This is where you have a more complicated logarithm to break into smaller, simple logarithms. And I'll just have you pause it here. And after you've paused it, I'll just show you the answer really quick. Sorry, I didn't have the music ready. Anyways, the answer is going to be log of x minus 2 log of y. And if you didn't get that, then ask me in class about what you got. You might just have it written a little bit differently, or you might have made a mistake, but you can show it to me later to see if you got something else. Anyways, we'll get more practice with using these log rules in class. It is kind of tricky stuff.